Hello and welcome to today's video. Today's video is for Advanced Geometry Chapter 1, Section 1, Patterns and Inductive Reasoning. So we're going to start out with a pretty easy activity to take a look at inductive reasoning. And so we'll do this one in class, but it deals with the area of a rectangle. So I'm going to skip to the next page, which has some notes on it. Inductive reasoning is reasoning that is based on patterns you observe. So inductive reasoning is, something happens, you notice a pattern, and then you make a reasoning assumption based on that pattern. It's not a proof. It doesn't mean it's always true. The cool thing about inductive reasoning is that not only do we do it, but you also see it in animals. If you've ever heard of Pavlov's experiment where he rang the bell when he fed the dog, and then every time he rang the bell, the dog started getting all excited and salivated. That's inductive reasoning. So a lot of things in nature do inductive reasoning. So we have a couple examples. Take a look at the pattern. Use a pattern to show the next two terms in the sequence. So the first one we're multiplying by 2. So for this one, the next one's going to be 48 and then 96. And the next one, we're adding one more line in the circle. So this one's kind of hard to draw, but we have 1, 2, 3 in the last one. So if we make 4, 1, 2, 3, 4, and the next one is fun. 1, 2, 3, 4, 5. A conjecture is a conclusion that you reach using inductive reasoning. Now, when we make a conjecture, we want to have a way that we make a conjecture that is going to come up with a reasonable expectation about what the result is. So I'm going to show you kind of what we do when we make a conjecture based on inductive reasoning. So make a conjecture about the sum of the first 30 odd numbers. Okay, and you might know this one, but let me show you. It's really the process that we're looking at, not necessarily the answer. So suppose I didn't know what it was. What I'm going to do is I'm going to say, well, let me start out with less than 30 odd numbers. Let me start out with one odd number. Well, that's just going to be 1, and the sum is going to be 1. Okay, let me do the first 2. Well, that's going to be 1 plus 3, and that's going to be 4. 3 odd numbers, 1 plus 3 plus 5, that's going to be 9. 4, 1 plus 3 plus 5 plus 7, and that's going to be 16. And what I can look at is what I started with. Well, here's 1, 2, 3, 4 odd numbers, and here's my result, 1, 4, 9, 16. And if you take a look at that, you notice what we're getting are perfect squares. 1 squared, 2 squared. So now that I have a conjecture that I'm thinking about, it looks like, 1 squared, 2 squared, 3 squared, 4 squared. What I'm going to do is I'm going to try a couple more just to make sure. So I'm going to try first 5. 1 plus 3 plus 5 plus 7 plus 9. And I'm hoping it's going to be 25, and it is. And one more. So 1 plus 3 plus 5 plus 7 plus 9 plus 11, and this is 36. Oh, this is not the first 7, this is the first 6. So now when I look at it, I'm pretty sure I can make a conjecture. Now, what I need to realize is this is just a conjecture. This is not a proof. And I can say that the sum of the first 30 odd numbers is going to be 30 squared, or 900. A counterexample is an example for which the conjecture is incorrect. So find a counterexample for each conjecture. The square of any number is greater than the original number. The easiest one to do is 1. 1 squared equals 1, and 1 is not greater than 1. Okay. You can also do fractions. You can connect any 3 points to form a triangle. If I draw a line and I put 3 points on it, those 3 points don't form a triangle. So any collinear points. Collinear means that they form a line. Any number and its absolute value are opposites. So an example of this, any positive number. So 2, absolute value of 2 is 2, and 2 and 2 are not opposite. Now, the nice thing about proving something's not true is you only have to show one counterexample. Okay? If I want to show that anything's not true, I show one example where it's not true, and then that statement is now false. To prove something's true, especially with inductive reasoning, you would have to show it worked for any example of it, which obviously for most things is impossible. There's infinite examples. We can't show they're all true. So we need to have a little better way than inductive reasoning for if we want to prove things are true. And that's it for today's video. Thank you for watching. Have a great day. Take care.